Good day wherever you are. I want to take you through chemistry paper 3 before we do organic analysis, inorganic analysis, qualitative analysis. I want to first take you through the prediction since all of the setting. From the year 2000, the iteration has missed how many times? 1, 2, 3. So for 24 years, the iteration has missed only twice. So 2024 it will not miss. So we have the iteration as our question. So we have the iteration 2024 is there. Then we have energy changes. Energy changes has been frequently also in a miss some few years. So 2024 we must have energy changes. Energy changes, we have it. We can be sure of that this year. And then rate of reaction was there last year, so this year no. Solubility curve, that one will not be there. Qualitative analysis, both organic and inorganic, that you can see from 2000, there is no here that it has missed and it will never miss. So qualitative analysis is a must, both organic and inorganic. So we will look at this in details. So first I want to take you through the energy changes graphs. What are you expected? In energy changes, we don't expect a student to draw a curve. There is no curve in energy changes. That's why I'm going to take you through. In energy changes, we have two types of tables. And I have given you the examples of the tables here. Let us look at the tables first before we go to the graphs. Now here we have a table with broken reading. Broken reading we mean the table will contain time in minutes. This is the same as a half. 0.5 is a half, 1.5 minute, 2 minutes, and then at some point here in temperature, it will have an X. It will have an X. That one is a broken reading. It is called a broken reading. So whenever we have a broken reading, ukiona table ambayo imeenda to temperature ikafika kwa 2 minutes kuna X. That one is called broken reading. The table is broken. We call it broken reading. Hapo I hope tumeelewana na wewe. So whenever we have this broken reading table, then the graph we expect should look like this. The broken, this one is for the broken. First, we must have this temperature here initial, because initial will not change. You can see we will from up to the broken point, we will have the same temperature, 26, 26, 26, 26. Hapo ndio hii 26, hapa ni 26, 26, 26, 26 mpaka umefika hapo mwisho. And sasa hapa hivi mali hii line iko ambayo tunaita reference now the broken, this will be 2 minutes. This one will be 2 minutes and this is our X. This is our X. And hiyo ndio inaitwa reference point. Kwa nini tunaita reference point? Now, ukishaweka hizi points zingine, you are going to extrapolate the line to our reference point. That way, this one will give us the maximum temperature. Here, hii line extrapolate, ikifika kwa hii mahali tulikuwa na broken line, then that's where our broken table here ndio tunasoma. So ukichora a straight line now here, you will get now the maximum temperature or final temperature. Now this is the temperature which will help you to find the difference. For example, inaweza kuwa ni 40, So 40 minus 26, you get the change in temperature. So when we have a broken table, you are expected nothing or less of this. You must have a graph of this. And this means the reaction was exothermic. For this case, it means the reaction is exothermic. Kwa sababu unaona tunaanza 26, tunafika 40. Therefore, temperature is increasing. The reaction is exothermic. I want to talk about the same broken table when the reaction is endothermic. What do we expect? The broken table and the reaction is endothermic. This is what we expect. If the reaction is endothermic, meaning temperature, you start at, for example, room temperature 23, and then when you add a certain solid, the temperature will start decreasing, will decrease. Therefore, utaanza hapa, you will write hapa, sitakuwa na 23 mpaka tufike 2 mahali x iko. Sasa kuanzia 2.5 hour, a minute, 3 minutes, you realize that the temperature is under 21, 19, so we will have a graph of this because the temperature will be decreasing like this. So our reference point is here, x, unaona hapa ndio tumechora hiyo, so this one will be 2 minutes. Therefore inamaanisha nini now? You draw, once umeweka hizi points mbili hapa, kwa mfano hii inaweza kuwa ni 19 na 20, tuseme 19, hii ni 20, so ndio hii umeweka 20, 19, so you have this one, so you have drawn a line, so you extrapolate this line to our reference point where we have 2 minutes, which is x. Kwa nini tunaita hii reference point? Kwa sababu at the 2 minutes ndio utaweka solid fulani, either ifanye temperature increase ama temperature decrease. Ya namna hiyo. So this one is for endothermic. So for endothermic, utaanza na room temperature which will be 20, 24, it depends where you are. And then ukiongeza certain solid, the temperature ita decrease. So final tutakuwa na kama 18 na initial ilikuwa 22. That was reaction. When you subtract it, don't put negatives there. The reaction is just showing us that the reaction is endothermic. So that one will be 22 minus 18, and you get the answer, which is 5 degrees Celsius without a negative. But you keep it in mind that the reaction is endothermic. Now I've finished talking about broken table. Now let us look at the table, the other table which is not broken. The table which is not broken. Now table without a broken reading. This is the table. In this table, now I'm not here, we will have time. Let me use this to remove this one. You can have volume, but let me use time first. So we will have time in minutes. So we will have 0 minute, we will have a half minute, we will have 1 minute, 1.5. So this time can be written in seconds, in minutes. So this one will be 0 seconds. This will be 30 seconds, 60 seconds, like that, 90 seconds, like that. So it can be in minutes or seconds, it doesn't matter. So this one will be 2 minutes. Now here, there is no x, there is no broken, therefore you will be told measure 50 centimeters cube of the solution provided, add the solid provided, immediately start a stopwatch. Start with a temperature, with a thermometer measuring the temperature. So once you add the solid, you start at 0, you find it as 0 ni room temperature. Kabla uongeze anything, it will be 24, 25, 22, it depends where you are. Ukiongeza hiyo solid, immediately you start a stopwatch. Ikifika half a minute, then you record. You record as you go. So you realize temperature will be increasing if the reaction is exothermic. If the reaction is exothermic, if whatever reagents you are given is going to produce heat, then the reaction will be exothermic and the temperature will increase. So assuming the reaction is exothermic, tutaanza na room temperature 24, then we will increase to 24.5, 25, 25, tuende 26, 26.5, then 6.5, like that. I want to tell you that in this reaction, you must ensure where the table is not broken. Is not broken, without being broken, where we don't have X. Here, at least hata kama utaona kwa thermometer yako, you must have some two values which are the same. Like ukifika kama ni 30 temperature, ukuwe na 30, ndio tena. So unaona ime increase, for example 24, 25, 27, 30. Lazima ukuwe na 30, alafu ndio ianze kushuka. Kwa 31, 30, 29. We must have something like that, because after the reaction is increasing, kuna mahali itafika i decrease. If after the reaction the temperature will start decreasing, kwa hivyo that is how we taught you. So at least you must have a constant of two numbers somewhere, which will help you to draw the graph of this nature. Now, for example, you will have this and this. This could be, for example, 37. Now, once you umefika maximum yako ilikuwa 37, alafu ikaanza kudecrease, ikafika 36, 35. Hapa ilianza 24, 25, 30, 37. Kwa hivyo hapa, sasa hapa hii graph haifai kukua hivi. Sawa? So once you have drawn the points 1, 2, now you extrapolate. You extrapolate the lines. Where they meet, that gives us the maximum temperature. You read this temperature here. In case the reaction is exothermic, this is what we expect. If the reaction is exothermic, this is what we expect. Don't draw this line here. We just need you to draw a line of best fit. Kama points ni mingi, zinaenda hivi, ingine ziko hapa, ingine inaenda hivi, unaachana na hii, unachora a straight line. Kama kuna hiyo inaenda, unachukua points ambazo ziko mingi, line of best fit, you draw. Now, then you extrapolate. Where the two dotted lines meet, that gives you the maximum temperature, na hiyo ndio itatusaidia kufanya what we call temperature change. So for the reaction which is exothermic, this is what we expect. For a reaction which is exothermic, we expected your curve to look like this. Now, what if we have an unbroken table and the reaction is endothermic? If we have this table where we don't have the X broken and the reaction is endothermic, we will have a table of this nature. We will have a table of this nature. A graph of this nature. Now remember, if the reaction is exothermic, obviously we will start at room temperature, which will be 23, depending on where you are. Then, once you add, so you will be told, measure solution whatever into a beaker, add solid provided, immediately start a stopwatch. Start the solution, the mixture with thermometer, and measure the temperature after every half an hour. Half a minute, or after 30 seconds, something of that. Then now, if we started at 23, then we will have a table 23. When you add the solid, you will realize that it's going to 22, going to 20, going to 19, going to 18, something like that. So we will have these points. So you will put your points like this. So if you have some points outside here, you draw most points in the line. The lines should have the majority of the points plotted. Therefore you draw a line. Si itafika hapa kama hii imefika hapa na hii imefika. So you extrapolate kama imefika hapo mwisho. Now you extrapolate like we have extrapolated here. You extrapolate here like this. So mahali the 2 points dotted line meet, this is where we will read the final. So for example hapa final itakuwa kitu 16 lakini tulianza 23. So when you do final 16 minus 23, the answer is negative. We do not have negative temperature for when you are doing the difference. We have negative temperature, yes, -4 is there negative, but you don't write that to in this one you give us that now the change in temperature is -7. No, we don't expect that. What we expect is that this one information is telling you that the reaction is endothermic. This information is telling you that the reaction is endothermic. Therefore, the difference is 23 minus 16, and we have 7 degrees Celsius. That's what it is telling you. So the difference here, 23, it is 16 minus 23, the final minus initial, but we don't need you to give us the negative because it is meant to tell you that the reaction is endothermic. So that is the graphs we expect in whether it is a displacement reaction and it is energy changes. Those are the difference is there's no difference. Like this one is for displacement, the same way it will appear. I hope I have explained well. I've said what I wanted to say for energy changes graphs. For example, let me look at this example here. Which table is this? Is this table a broken or not broken? This table is not broken. So we expect to have either the graph should be like this. For this one, the graph itaenda. We expect to have a graph like this and like that. So if it is, as you can see, this one temperature is increasing 23, 24, 26, 27, 29. At some point unaona hapa kuna 32 na kuna 32. We expect your values to have, hata kama utaona itabidi tu ujipange ukuwe na some constant somewhere towards the end. After that, then there must be a decrease. So after that, ushaweka hizo constant mbili 30, 30, there must be 31, 30 na 29. So that you can be able to draw this line. Then from there, you can now extrapolate. So hapa now, that is where you read the final temperature. That's in case the reaction is exothermic, like this one is exothermic. So an example here is saying, measure exactly 6 centimeters of metal M provided. Measure 40 centimeters cube of solution A and transfer into a 100 ml plastic beaker. Wrap the plastic beaker with a tissue paper. This is meant to avoid heat loss. Measure initial temperature and record. Immediately place the metal M into solution A in the beaker and start a stopwatch. You see that? Record the temperature after every 30 seconds. Every 30 seconds is half an hour. So ukipewa sasa time in a half a minute, not an hour, half a minute, utasa tena unaanza unakwama nini? You should know that a minute, a half is the same as 30 seconds. 1 minute is the same as 60 seconds. So there's no kuchanganyikiwa hapo. Now this graph I have showed you how it should look like. So you draw a graph of temperature against time. So you draw a graph of temperature against time. So this one will repeat time and this one will repeat temperature. So temperature should be on the y-axis, time on the x-axis. So like this one, I will show you how the graph looks like. Now this is the graph for this one, temperature against time. You can see kuna points hapa iko out. Look at this point here. Look at this point. Naona? Na kuna point ingine iko hapa. So usilazimishe kila point ingie kwa line. No. Ukiangalia sasa hapa kulikuwa na hii point nimesako na kulikuwa na hizi zingine 1 2 3 4. Kwa sababu hizi 4 zilikuwa mingi na ndio ilikuwa nachora straight line, you draw a line of best fit using majority of the points that enters into the line. Hapa kuna hii point, kuna hii, kuna hii, kuna hii. So umeona hii iko nje. This one is almost out. So alichukua hii point na hii akachora line hii. So unaona hizo ni 3 na zenye ziko nje ni 2. So be accurate, you take the majority of the points and draw a straight line. Sasa line yake ilifika hapa na hii ikafika hapa. Ndio hii sasa ame extrapolate mali zina meet, you read the x, the y coordinate here, which gives you the maximum temperature. Maximum temperature. So these are the things you must have. Hii lazima uwe umesoma umeiva vizuri kufanya hizi calculation. It's very simple, but for example this one is asking to calculate the molar heat of reaction given this one. That one is but you should know that the change in heat it is given by mass. Which mass is this? Mass of the solution times specific heat capacity which will be provided with, and then change in temperature. So this mass must be, you convert from grams to kilograms. Like here, the solution we used, this is the mass of the solution. Our solution was 40 to the measure 40 grams, 40 centimeters cube. 40 centimeters cube is the same as 40 grams. Why? Because the density is 1 gram. So here you would have written here now, if you wanted to ask to calculate the heat change, you simply take 40. This is in grams, you divide by 1,000 to change it into kilograms, times specific heat capacity 4.2 times our temperature change. For example, in this case was 9.5 times 9.5. So the answer you get here is in kilojoules. The answer you get is in kilojoules. This J should be in capital and J should be in capital and K in small. So this one is the heat change. So the number of moles of the mass of the metal used was able to produce this. Now you will ask for 1 mole if you are asked. So it depends on the question, the way it comes. Let me take you through quickly through organic analysis. I want just to remind you the reagents that we have and what you are expected. When you are given acidified potassium permanganate, which is purple, the color is purple, then you add 2 drops of acidified potassium permanganate. If the color changes to colorless, meaning that the purple potassium permanganate is decolorless. To decolorless meaning the color changes from purple to colorless, and you are using acidified potassium permanganate, then you should know what could be present is an alcohol, an alkene, or an alkyne, the double bond, the triple bond. That one is simple for organic analysis. Ni hivyo tuna master. And if there is nothing that happens, it means that the purple color persists. The purple color of acidified potassium permanganate remains the same, then it means hizo zingine hizo wenye tumeandika absent. So the word present and absent is very, very important. If you don't write that, I guess you must be in a bad side. So first, this one is a sure bet thing. If you are adding so the answers are only like that and there's nothing more that is going to change. We are adding bromine water. The color of bromine water is yellow. We call it yellow bromine water. So if the color changes from yellow to colorless, then it means only 2 For bromine, we need two things only. Which one are those? If the color changes from yellow to colorless, or you say bromine water is decolorized. To decolorize means the color of bromine has changed from yellow to colorless. So simply write bromine water is decolorized. In other words, the color has changed from yellow to if you sasa hii, this one is very important wakati ujui the color. If you forget the color of bromine, then just write bromine water is decolorized. Utakuwa umejisave. But if you say a different color, then you go wrong. Therefore, simply say bromine water is decolorized. If it is decolorized, then it means the alkene, the alkyne, the double. Usiandike maneno at alkene or alkyne. We need you to write these bonds. You write C, double bond, C, and make sure each carbon is surrounded with 4 covalent bond. Ndio maana tunaweka hivi. Or the double bond, the triple bond, sorry, is present. If the color does not change, you just write the is mbili, andika absent. If the color does not change. So ndio hii bromine water not decolorized. That's okay. Or yellow color of bromine water persists, meaning it remains yellow. Then this one is absent. This and this is absent. I don't know why people fail, especially organic analysis, because these are the simple things you will get and they will never change. The problem is students make wrong observation. So if your observation is wrong because of carelessness, umegusa hii, mikono ni chafu, umeshika hii, umeshika hiyo, now you will make wrong observation and the answer will be wrong. Inference will be wrong. Therefore, in practical analysis, you must ensure that whatever the way you handle the reagents, the solids provided, you must be very careful. Otherwise, if you be careless, your marks will be careless also. Add 2 drops of acidified potassium dichromate 6. Now this one, the color is orange. Acidified potassium dichromate 6, the color is orange. So what happens when you have acidified potassium? Like you see here, my pen here, you could ni acidified potassium permanganate uko nayo. On my left hand here, let me use this. Assuming this is now the test tube holding your solution. Now you are adding 2 drops of acidified potassium dichromate. This one is orange. So ikifika hapa ndani, that color of orange changes to green, maybe after warming or you don't warm. But if it changes to green, maybe after warming, if you will be told to warm, there are some reagents which it will change without being warming. So if it changes to green inside here, now your solution is green, then it means alcohol is present. So acidified potassium dichromate actually in organic is simply used to confirm that whatever reagent you are given is an alcohol. If the color does not change to green, if the color remains orange, then alcohol, ROH, is absent. So now tu ni majibu tu the same. The only thing you need to, you make correct observation and then the inference is as simple as you can see. Now you will told scoop solid D, scoop solid F, scoop solid M, whichever name, it doesn't matter. Scoop a half of solid K, heat it on a clean, non-luminous flame, then make the observation. So we expect the solid to heat, to burn in 2 ways. One, to produce a yellow sooty flame. So you say solid whatever, solid K burns with yellow sooty flame, meaning it is yellow sooty flame. If it is burning with a yellow sooty flame, then it means an alkene and alkyne is present. Unsaturated organic compound. Unsaturated tuko nazo mbili, ni alkene double bond na triple bond. Nimesema unaandika this bonding here. Don't write words that are alkene or alkyne. No. If the solid now burns with blue non-sooty flame, blue non-sooty flame, blue non-sooty flame, then it means an alcohol is present. You can even say an alkane is present. Alkanes are unsaturated, so they are present. Alcohols and alkanes are saturated, therefore they burn with a blue non-sooty flame. Whenever you are given to use a universal indicator, we are testing for the pH. If the pH is 1, 2, 3, then it is strongly acidic. If the pH is 4, 5, 6, weakly acidic. If the pH is 7, that means the solution is neutral. If the pH is 8, 9, 10, it means weakly alkaline, weakly basic. And if the pH is 11, 12, 13, 14, then it means strongly basic. The next reagent I can't see in this one, whoever was preparing it might have forgotten, is number 7, sodium hydrogen carbonate. So to the next portion, add sodium or the sodium hydrogen provided. So whenever you are adding sodium hydrogen carbonate and you already know you are in organic, you are doing organic analysis, we expect effervescence. So the observation, we expect effervescence. Effervescence. The name effervescence gives students sleepless night writing, but you don't need to write effervescence. You can write bubbles of colorless gas produced. You don't need to write bubbles. You can write whizzing occurs. So you can use whizzing. What do we call effervescence? What do we call bubbles of a colorless gas? What do we call whizzing occurs? Ninio. So when you add, you have your test tube. Now you have some solid here. You are adding that sodium hydrogen carbonate. You add BAP. Na unaona inachemuka, ni kama Coca-Cola wakati umefungua soda inachemuka ile kuchemuka. That is what we call effervescence. The way it looks, it is like it is boiling. That I hope every and every one of you has opened a soda and sometimes inamwaika. So ile kule kuchemuka, ukiona something like that, hiyo ndio tunaita effervescence, ndio tunaita whizzing, ndio tunaita bubbles. So if these ones occurs, then you need to tell us that RCOOH is present. So RCOOH is present in nini? This one we are telling you are telling us that there is an alkanoic acid present. Because we are in we are doing organic analysis, it is important you use this to tell us that alkanoic acids are present in the whatever provided. So testing of cations and anions, that one is called inorganic analysis. Maybe you will do it later, this one.